Hey guys, I'm just going to review some of the questions that might be helpful for your redo tomorrow. You can use your notes tomorrow and then just submit it right after. There's not too many questions, so get that done, and it's only available tomorrow, so all day. And then once you submit, that can replace your mark that's currently in your student portal. So let's look at this first example. Whenever you have words that you have to rearrange, the number of distinguishable, meaning different arrangements of all the letters in the word bookworm is, so this would be a permutation question where you have spots. So in this case, I would count how many letters I have. I have 8 letters. So I would go 8 factorial. Now, this would be the answer, and I would calculate it if there were all different letters. But because we have repetition, we're going to have to divide out the O's. There's 3 of them. And then there's no other B's, there's no other K's, W's, O. The O's are the only ones that are identical. So you're going to have to divide it by how many letters there are repeating, factorial. Okay, so if there was 2 sets of them, you'd have to have another factorial as well. So this is what you'd place into your calculator, and just to remind you where this stuff is in your calculator, you'd go to your calculator and go 8 factorial, which for you guys would be math, probability, number 4, and then you divide that answer by, in our case, the 3 O's, math, probability, and then number 4. Enter, and you should get 6,720. Okay, so this is what I would be looking for is on that redo. If there is a 4-digit number, just write it exactly how you see it in the space provided for the numerical response. How many routes are there from point A to B on the map if you travel only going south, meaning down, and west would be going to the right? So we're only going towards B. We can't go to the left and we can't go up. So we'd start by labeling the side lengths as 1s. Let me fix that. It should be 1. 1, 1, 1, 1, 1, because there's only one way to get to all these vertices here, these points. And then you would add up the 1 and the 1 to get 2. And then you'd add up the 2 and the 1 coming down to give me 3. The 1 and the 2 add up to 3. The 3 and the 3 add up to 6. The 1 and the 3 add up to 4. The 1 and the 4 add up to 5. The 1 and the 5 add up to 6. Oops, 6. The 6 and the 4 add up to 10. Now here, there's only a 6 coming because there's nothing coming down towards it. So that should be a 6, that should be a 6, and that should be a 6. There's nothing coming down towards them. And then you can continue that this would be 16. Here you would have 10 plus 5 equals 15. 6 plus 15 equals 21. 15 plus 16 equals 31. 31 plus 21 equals 52. 6 and 16 equals 22. 22 plus 6 is 28. 22 and 31 is 53. So I can start shifting to my calculator. 28 plus 53 equals 81. 53 plus 52, these two numbers add up to 105. 81 plus 105 adds up to 186. Now here there's nothing coming towards from the left, so there's nothing coming towards it, so it's just going to be a 52 continuing downwards. And then you'd say 105 added with 52, these two numbers, gives me 157. 157 plus 52, these two give you 209. And then coming downwards, 186 plus 157 gives me 343 from these two numbers. And then lastly, to get our answer, 343 plus 209 gives me 552 as my answer. Okay. Our next example, it's saying the number of different cars that Simon can choose from. Well, whenever we have to choose different stages, this is called the fundamental counting principle. So there's actually 4 stages we have to pick. So I'm going to put 4 spots. We have to pick the model. We have to pick the transmission. We have to pick the interior color. And we have to pick the exterior. So this is the interior and this is the exterior color. So all of those are stages that we have to pick. Well, always between the stages, we multiply for fundamental counting principle. And you would just say that there's 4 choices for models, 2 choices for transmission. We have 2 different interior colors and 5 different exterior colors. Then you would, in your calculator, multiply all these answers together because there's no specifications other than how many different cars can you make. And you should get that there's 80 cars. Our next example, it says Sally wants to decorate one wall in her room with movie posters. She will hang 5 of the 8 posters that she chooses in a single row across the wall. If Sally places her favorite movie poster in the middle, then the number of different poster arrangements that are possible is, well, she will hang 5 of the 8 posters, so we should only have 5 spots here. Now, order matters whenever you are putting something in a row, so this one is a permutation question. So order matters in permutation. That's when we use the letters NPR, or we can use that factorial or spot. So those are different ways to show these permutation questions. So we know that her favorite movie poster has to go in the middle. So this is the middle spot, and she would only have one favorite choice for that. Now, since from the 8 we've already used 1, we would subtract 1 from that, and there's 7 more posters to place. They don't give us any other rules, so we would say 7, then 6, then 5, then 4 for the rest of the spots. So we would multiply these numbers together to get 840. So our answer is B. Okay. The next one here, logging truck license plates in British Columbia begin with the letter T, followed by 5 digits. 1, 2, 3, 4, 5. As shown below. So we have a letter, and then these guys are 5 digits. The first digit must be a 0, 1, 2, or 3. The remaining digits can be any digit from 0 to 9 inclusive. Okay, so the total number of possible logging truck license plates in British Columbia is, well, they say that the British Columbia license plates begins with a T. So this one has to be a T, which means that there's only one available option there. So T has to go there, so there's only one choice. The first digit afterwards has to be 0, 1, 2, or 3, so that means there's 4 choices here. The remaining digits can be any digits from 0 to 9 inclusive, and it seems like repetition is allowed, so we would put 10, 10, 10, and 10 here. Okay, so 0 to 9 means that there's 10 choices to pick from. Then we would multiply all these numbers and get 40,000. B. From 1951 to 1981, the first digit of every 3-digit telephone area code in North America was the numbers of 2 to 9 inclusive. The second digit was either 0 or 1. The last digit depended on the following rules. So the first 3 numbers of every 3-digit area code, so let's put 1, 2, 3. So we're talking about the first digit of every 3-digit area code was the numbers 2 to 9. inclusive. So we know that this one is going to be 2 to 9. So I'm just kind of writing these rules down. The second digit had to be either 0 or 1. And the last digit depending on the following rules. Well, if the second digit was 0, the last digit could be any numbers from 1 to 9 inclusive. If the second digit was 1, the last digit could be any number from 2 to 9 inclusive. Digits could be used more than once. So what I'm seeing right here is that there's cases. So this would be case 1 and this would be case 2. So I'm going to kind of arrange that. So let's talk about case 1 first. We know that for our 3 digits, the first digit has to be 2 to 9. So 2, 3, 4, 5, 6, 7, 8, 9 means there's 8 choices right there. The second digit was either 0 to 1, but in case number 1, we know that the second digit has to be a 0, so we're going to place a 1 there. There's only one choice, which is 0. The last digit then means that there could be any number from 1 to 9, which means that there are 9 choices. The digits are allowed to be used more than once, which is why we can write this. So then I would multiply these numbers together, and I get 72. Case number 2 would be where we have, again, 3 spots. We still have 2 to 9 for the first spot, so we're going to have 8 there. But now we're going to have for the second digit a 1, which means that there's one choice if a 1 is going in there. The last digit could be any number from 2 to 9, so over here there's 8 choices again. So what we're going to do is multiply those numbers, and we get 64. Now between the cases, if we want to know all the different phone numbers that can be created, we're going to add the two answers together. So 72 plus 64 gives us 136. So our answer is B again. Now, another thing that I just want to review was combinations. This is where order does not matter. Right? So this would be anything where I have like 5 girls and I want to choose 2 of the girls. I would go 5, choose 2. So I want to choose 2 girls to do the same job. Okay. This would also be useful for cards. Whenever I work with cards, remember you're going to have to do cases whenever you see the words at least or at most. So this means there's cases. And then you're always going to make sure that your R's add to how many cards you have. Okay, and then so just make sure that your numbers make sense. Okay, so there's a few examples in your notes, so make sure you look at those ones. So order doesn't matter when you're choosing something that's going to do the exact same thing. So if they're going to do the same job or there's a card situation, that's when you use this NCR. Okay, so make sure you pick the right